Today I'm gonna look at some more processing basics. So if I get my processing open there, and I've discussed previously in another tutorial void and setup. Setup and draw. So I'll go ahead and set up my sketch in its sort of basic skeletal format. So if I do void setup with all its little accoutrement, and then void draw. Again with these things. It's a basic template that most of the time you're going to end up following. I declare size, function, say 500 by 500, nice square, and then maybe make a background. My lime green that my son enjoys so much. Lime green and black. It's kind of nice. I don't mind it so much. All right, so if I do that, if I run, you'll see a nice lime green canvas on which to do some drawing and such. Now, I just wanted to sort of cover some basics. One thing is really very simply, I just sort of taken it for granted, is simply this idea of the semicolon. Semicolon is used here in processing, which essentially is Java. It's based in Java. It's a high-level Java sort of wrapper, and basically just ends your line. It tells the computer, the compiler or whatever, that you're done with that line of code. So background is finished. If I try to run it without that, it says it's smart enough to know the IDE, or it's smart enough to know that I need a semicolon there. All right. And also, so there you go. So you're going to end most lines with semicolons. The other thing, just to actually state, is that most things aren't like the white space doesn't seem to matter. So in most cases, so if I put loads of white space in here, I guess space bar, and run that, it'll run it exactly the same as if I didn't have all those spaces in there. And also, in some cases, hard returns, though I think in this case, so in this case, I can put in as many sort of hard returns as I want, and it's not going to make a difference. It's not going to impact my code. It just sort of ignores those hard returns. It's more for formatting. And also, semicolon, you need to, so I guess that sort of explains the semicolon, because you need to tell the computer you're done with that line of code, because you can actually use the same line physically here on the same space and do another, another line of code there, and it'll still see those as two separate lines. So really, semicolon just tells you that you're done with that little bit of code. All right. And let's talk a little bit about these parentheses. Here in this country, in Northern Ireland, and in the UK, they call these brackets, I guess, but I'll call them parentheses because that's what I'm used to. So anyways, parentheses here, open and close parentheses, generally speaking, are attached to a function, which we'll explain in another tutorial. Generally speaking, they're attached to a function, and they're usually used for arguments. So the size function is setting the size of my canvas, right? And it's looking for arguments of width and height. And so in these parentheses, you're setting arguments. So background is looking for 3 arguments, which is your red, green, and blue settings between 0 and 255. All right. And all these functions will have these parentheses. Now, even when you do things like, say, I showed you no fill, even when you declare a function, you do have to declare an empty set of parentheses, because that also tells, the parentheses also tells the computer that this is a function. And I think I showed you in an earlier tutorial, there's a difference between sort of reserved variables and functions, so which are named the same. So there's a thing called like frame rate. And if I actually print this, and we'll talk about print in a sec, more explicitly, if I print my frame rate, you see it's printing down there, here. And basically, frame rate is, in fact, a floating point number. So this pink frame rate right here, without the parentheses, even though they're within the print line parentheses, is giving me a reserved variable. This frame rate, this word, frame rate with the capital R, is always going to report to me the current frame rate at that particular frame. Okay, what that particular frame sees is the actual frame rate. All right. Now, like I said, it can be confusing. That's why you need your parentheses. You can also have a frame rate Same spelled exactly the same way with exact same capitals, but with parentheses. Now this is the function frame rate, and in fact, it's used to declare an actual frame rate. So if I want to make my frame rate say very slow, like 0.5, that's once every 2 seconds, you'll notice. Well, I better do it up here. You'll notice that, and actually, this is actually done often in draw. I mean, in setup, so you don't have to declare it over and over again, I think. So if I do it that way, I'm only getting a report once every 2 seconds because that's my new frame rate. I've declared a frame rate. So all that, just not so much to talk about frame rate, but more to describe the difference between a variable or a name that is associated with a variable and a function. And these parentheses denote a function. So even though you don't have an argument, any arguments in your parentheses for your function, you still have to include the parentheses. So I guess I'm beating this dead horse really to say that, because I think a lot of errors come that way. Sometimes folks, I know I do, forget the parentheses and it throws kind of a weird error and you're not sure why. Well, it's because you didn't include parentheses for the function that you thought you were declaring. Okay. Let's see, what else do I want to talk about in these programming basics? So the parentheses and semicolon, we mentioned that, and then these curly brackets, which I sort of mentioned in passing a lot, but we'll talk about more explicitly here, is the scope. All right, so you have sort of a global scope. That's everything in the just sort of white space, okay, including these things, which are functions or methods. All right, these functions then have their own scope, and so that means that void draw includes everything between these two curly brackets, all right? And anything outside the curly brackets have nothing to do with draw anymore, all right? So only things that are run between these two curly brackets are run every frame. Only things between these two curly brackets are run once at the beginning of the setup, and then you'll have a number. And when we talk about functions, you say you can write custom ones, you know, blah, blah, blah. And that's a custom function now defined by the scope. Also, you'll notice a lot of things when we get to them, like if statements. Oops. It'll declare the scope of that if statement. So if 0 equals 0, run everything within those two curly brackets. All right, so curly brackets, semicolons, normal brackets or parentheses for arguments. Let's talk about print. So there's two general print commands. The most common one, I think, is println, println. And basically, it'll print anything within its, so it takes an argument. It'll print anything within here. Don't forget the semicolon. And then it'll give a hard return. So it'll give a new line. So it'll only print one of these per line. So if I go hello and run that, it's going hello one time per frame. Okay. And you can just do print. If you just do print, it's not going to put the hard return. It's just going to print the long line of hello. See, one after another. It's kind of interesting. It looks like lohe, 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 to me anyways. Okay, and so that's print and println. And you can look more, I'll just give you a couple of things here. You can look more into detail about sort of concatenating strings and adding things together. But oftentimes, if you want to print multiple things, you can print like numbers. For example, hello plus 1. It'll print hello 1. It'll just stringify that 1. And you can just use this plus to basically mean concatenate, to put together these strings or items. And I can do, so if I want to add sort of a semicolon spacer there, something like that, or just put those in quotes, and then plus, oops, and then add something else, something like that. Now it has, it inserted those things. And you can also insert variables, for example. Okay, and then we'll put that, maybe put another spacer in there. Space, space, comma, space, space. and then plus the X, which is a float now. So you'll see hello, yo, comma, 256666. Okay. So that's printing there. Semicolons, printing, brackets, curly brackets. Let's see. Is there anything else I want to? Oh yeah, commenting. Let's cover all these three things here, or all these many things, just to get these out of the way, and so I can say I've talked about them. So commenting, and this is typical for a lot of different programming languages, I suppose, is if you want to come out a single line, you do // and see it turns gray for you. That's nice. It tells you that that's been commented out. But that only applies to the line, so those are the only thing. So now I've gotten rid of my size. I get rid of my background. It's reverted to its little default little gray little postage stamp looking thing. And we can uncomment those out. Sometimes it's handy for debugging, well, for lots of things, for adding comments first and foremost, but for debugging, you can sort of take away certain lines to see if that is the line giving you trouble. Also, you can do a paragraph comment. So if you want to do more than one line, you do / and then asterisk to start, and then you need an ending tag as well. Asterisk /. So /* to start the comment, and */ to end the comment. So everything in between those two now it's just a comment. It's commented out. So run that. There's no background, but the size is back. All right. Okay. Well, I think I'll end that there. But in summary, we talked about semicolon to end your lines. We talked about the fact that white space doesn't seem to matter. You can put white spaces, and you can do hard returns, and they're not really included in your sketch. We talked about the fact that but semicolon is needed to denote that that's the end of that bit of code. We talked about these parentheses, which often are used to declare arguments within the functions, such as background. It needs the color you want your background to be made, but that's within these parentheses. And also the fact that, again, like no, fill, that functions, even though they don't have arguments necessarily, that's just saying we're not going to fill the thing, need the parentheses. We talked about curly brackets, which is scope for functions, scope for if statements, later on for loops, all kinds of things. It's basically telling you, what you declared. So this draw, what's included in the draw? Well, everything within these curly parentheses. Okay, and we talked about printing. Print without the ln. Println is going to print everything you asked it to print and then give a hard return. Just plain print is going to just have one thing after another. And we talked about commenting. Single lines are // and paragraphs are /*. */ and you can even, like, if you just want to sort of make a little comment within, within, that's sometimes a handy way to do. So you don't have to do it at the end of the line. You can say this one here is the green value. And then you can just end that comment there, use that kind of commenting. And so it's just going to put a little comment within your code, but your code is still good to go. It's just sort of inserted there as well.